Well, hi and welcome to my shop, and thanks so much for joining me here so I'm not all alone with this radio. So yesterday I tested the output tubes, and I think I've got 2 functioning output tubes in here, but still this radio is not operating. So I think I should carry on with the tube testing approach at this point, because otherwise I could be chasing something in this radio and it's really a tube. One thing the radio was doing right at the end, it was making a lot of noise. Lots of pops and clicks and things like that. It's possible all that was coming out of a tube. Tubes can develop shorts inside them that end up sounding like that. I guess it's breakdown currents or something of that sort. So carry on with the tube testing, but first, so I have a tree in my backyard that's just about named after me. I have a linden tree in my backyard. At this time of year, it's the fall of course, it starts dropping its leaves. You can see the brown leaf here. I'm showing you this because this is just an amazing piece here, because somehow this tree figured out that if you stick the seed way out on a stick like that, especially a bent stick, then this thing becomes a helicopter. I'm going to drop it in front of the camera here, but who knows. Well, you kind of get, maybe you saw that go by. Yeah, so it's a little like a maple key. Everyone's familiar with a maple key, but maple keys are even simpler, right? Because the seed is just out here and it has a wing. But look at this thing. Really. But what's really amazing is you and me. You and me are really amazing. This isn't nearly as amazing as you and me. Okay, now tube testing. So let's see, I can go from the, I can start at the antenna end and work my way back to the audio. Why don't we try that? So that means the first tube would be this one. This is also where we find out if really the correct tubes are in this radio. Because once in a while... Oh, what about that output tube? Was that the correct tube? That E tube? Marconi, made in Canada. Where's the label on this tube? Oh no. These ones are seldom rubbed off. Oh, it's right here. Looks like it says JAN. It might be a Joint Army Navy, which is an American designation. Yep, that's what that is, JAN. And then below it says 6S7. 6S. Probably a K. You know, something that happens in these radios, people pull the tubes out and then they shove them all back in wrong. So who knows? 6S something. We're going to need to look at the schematic to sort this out. Maybe I'll just take a quick peek at it here, and if I can find it, which would be a good idea. Yeah, I'm going to have to. It's going to take me a moment here. Well, if it's the right, this is a 6SK7. You know that the K is just rubbed right out. I have my magnifier here. Let me just take a little look. Maybe I can see it. It's amazing. That could be a Q, that could be a K, that could be anything at all. So it's a 6S?7. Now there is another 6K7 in this radio, which we would want to test at the same time. But there's also a 6SQ7. Did somebody mix them up? Okay, so I think this is going to be the 6SQ7 here. Oh my gosh. The label is gone on this one. Oh my gosh. Oh. Well, I better put this right back in, or I'm going to get these mixed up for sure. Well, the potential for a wrong tube here is really high now. The potential for me to mess this up further is really high too. Let's put that one back in. Okay, the other 6SK should be this one. There we are. Fine, I got one with a label on it. 6SK. And then the one that's left should be a 6SA7. 6SA7. Okay, let's put that back in. So these are probably both correct. That's probably the correct tube there too, but we can't know until we test them. Just stare at them all day. Let's give them a test. Okay, I think we're ready for the first 6SK7. That's definitely what this is. Just double checking everything here. 6SK7, 6.3, signal level 2. Bias is 10 low. 17251, 17251. 4634, 630, 44. C. So a good tube. Actually, it's not even a good tube. It's a tube at the point where you should reject it would be 1520 on here. So 1520 is pretty much straight up on the pointer. Okay, let's see. Just give it a moment to warm up a bit. Shorts. Done. Will it go halfway up here? Still going up. So again, even though it may be past the rejection point in the sense that in normal conditions you would reject this tube, I wouldn't reject it myself. This isn't 1950 and I'm not selling tubes to make a living. So it's actually coming up around 1300. And what was the number supposed to be? 1520. So weak, but it's there. Okay. Next. This is my own radio. Maybe I want to get out some good tubes. I have lots of 6K7s. Lots and lots. Now, this is either a 6K7 or it's the wrong tube. We may find out doing the short test. If it's the wrong tube, we may find a short where you wouldn't expect it. Nope. And if the test goes well, then I think we can be pretty darn sure this is the 6K7. Very good. Well, not very good. No, not very good. Two tubes testing similarly in the worn out zone, but they test functional, so I wouldn't write them off at all. Let me stick them back in the radio. I don't think this could cause the radio to be non-functional. In you go. And it is completely non-functional. In fact, it's non-functional even if I stick an audio signal into the audio amplifier. So let's go after the detector tube here. Oh, okay. This is the no name. This is the supposed to be a 6Q7. Looking very, very carefully. Somebody really polished this tube up. No, I don't see anything. Sometimes it's stamped right in the base here. Let me just take a look. 6SQ7 stamped right into the base. Okay, no doubt about what this is now. 6SQ7. 6SQ7. Okay, signal level 1. 18L on the bias. 25100. Make sure I'm doing the right tube here. 25100. 25100 and 3760. 3760. 37 for the meter, fudge factor. Plate is on F. In we go. So we're testing the triode first. Now, this is a likely target. Like if this tube doesn't work, if the triode doesn't work, we would get kind of what we're getting out of this radio. If the diodes are the problem, I think touching the volume control with a screwdriver should have been noisy. So maybe we're going to find a dead triode right here. Let's see. Nothing shorted. And we're supposed to get up to all the way to 760. So that's 1,000. So 760 is about there. What do you do? Good? Good. That's good. Now we need to test the diodes. So it doesn't matter. Pull the tube out of here. I need more light on it. 2013P. 2013P. 2013P and 0760. 0760. Sensitivity 48. The plate is A. Diode test. Plate 1, plate 2. I believe most of these tubes are sharing the cathode between the triode and the diodes, but I'm not sure of that. I'm really not sure of that. Which would mean if the cathode is contaminated or worn out, then this tube wouldn't work, diodes or triode. Okay, must be ready now. No shorts showing up. You know what? I got another camera shot of this. We forgot. How about that? Now I'm going to push the GM. We're looking at... No, don't put the GM. This is a rectifier diode. So diodes just have to get past that spot there where it says diodes. Okay. Oh, weak triode. First diode weak. Second diode similarly weak. I would say that the cathode is worn out on this tube. Now we got weakness going on everywhere. Could this explain why the radio doesn't work at all? I don't think so. But I think we're going to need a new one here. An alternate one. Okay. What do we got? Now we got 6SA7 to do. Let me pull it out here. So this is another very important tube. I guess they're all kind of important to make the radio operate. 6SA7. Signal level 2, bias 9L, 27345, 2, 7, 3, 4, 5. I'm double checking as I go. 1650. Can you do that? 1650. 45. Cheat factor on the meter. C, where the B plus goes. Old tube. Now, the tube testers like, oh my gosh, you've been looking at the meter the whole time. That's crazy. Tube testers like this, they don't try to operate the tube the way a radio would operate it. What's actually happening inside here is it's almost shocking in a way. I don't know about this particular tube tester, but in many of them, they're just throwing AC currents at the tube. The plate is not even a properly rectified DC. All this kind of stuff. It's really kind of crackpot when compared to how these tubes really operate. It's crackpot. That's just about it right there. Plug them in. But what the designers of these tube testers know is that under those conditions that the tube tester sets up in the tube, you can measure the mutual conductance, transconductance. Regardless of the fact that the tube is operating in a very weird way. And why do it that way? Cheap. Drive down the costs. 6SA, 1100. So we should be coming up just past this 1000 mark here. Oh, let's switch cameras again for the, because you can hardly see it there in that camera. Here we go. GM, please. So that's well over 1000. Whole tube test. Well, it's 1100 where it's really, there's the reject point. So this one is just a little above 1100. But again, this can't be responsible for a dead radio. No, no, no. It can't be. Can't be the killer. What's left here? So there's an inverter tube. I have a lot of trouble thinking that a bad inverter tube would silence this radio. Let's take a look and see. What is it? Oh, come on, not again. Huh. Somebody's gone and rubbed off the... I think I'm seeing 6SQ7 there. Is that correct? This is a 6SQ7. Is that what's supposed to be in there? As a inverter tube? Let's check the schematic together on this. So yeah, there it is, right there, 6SQ7. Funny, it seems like a bit of a waste, but maybe what they're doing is they want to use exactly the same triode, or even make this. Yeah, that is probably what they're doing. They just want to use the very same tube. So it's got a couple of diodes in it. This means we've got, hey, this means we've got another 6SQ7. Maybe I can swap these. Let's go back to the tester and see if this one's a better one. Because this guy's just inverting the signal. This one is busy detecting it. Now, I'm going to get these tubes mixed up. For sure. I'm going to get them mixed up. This is the one I just tested. I'm going to put this one back in the radio, back in its original position. This is the inverter. Let's see what happens here. So we're all downed up for a 6SQ7, aren't we? Famous last words before the airplane crashes. 25100. 27. No, what was it? I must have been. No, I wasn't doing a 6SQ. Oh, I saved the airplane. 6.3118 L. I saved the airplane, but we haven't landed yet. 25. 25100. 6SQ 25100 3760. These don't sound familiar to me. 3760. Maybe they do. 37 F 25100 3760. 3760. Okay. Ready to go. Inverter tube. No shorts. 760 up to about here. Ooh, hey, this one should be in where the detector is. Of course, I'm testing. What am I testing? I'm testing just the triode. Is this a much stronger triode? You would think you'd want both these tubes to be of similar strength. If they're both feeding into the two output tubes, you would want them to be similar in strength, I think. Okay, diode test. 2013P. Let me just make sure I got that right. 2013P 0760 48 A. Is that right? A 6SQ7. Yep, that's right. A. So I'll bet you the diodes are better in this one too. And you know, if it's a worn out a cathode, then if it tests good on the triode, it'll probably test good on the two diodes. If it's not, if the cathode's not worn out. Get all that straight. Rectifiers, diodes to here. Here we go. Diodes just above this diodes okay thing. Hot diggity dog. So this is a much better. Yes. What exactly a hot diggity dog is, I don't know. Here we go. So I'm going to put this in the detector position. Whoops. I'm going to put this into the detector position and put the other one into the inverter position. But we're not finding the dead tube I was hoping for. Okay, let me swap these around here. Can't see what I'm doing. Now it could have been just unplugging and plugging these tubes back in has fixed something, because it could have been a bad tube contact. It certainly caused the kinds of crackling and everything that we heard. So we need to test the radio again at this point. See what it'll do, if anything. All tubes in. All tubes are in. Volumes down, switches off, switches on. Tone about part way. Don't know what band we're on. We'll find out pretty quick with the really fancy lights. Are we good to go? We're good to go. I didn't really do anything here to be too concerned about in terms of short circuits in the radio, but let's just keep an eye on those dim bulbs. There they go, behaving the same way they behaved. Good. Back over here. Say, hey, Mr. Radio, come right totally to life now. Which I don't expect. We're running them on 95 volts. Seems pretty quiet to me. Let's fiddle with the volume control with my noise injection here. I don't recommend anybody do this. I don't recommend I do it. So let's do it like this. I'm going to grab onto the shank here. What was that funny sound? Was that my stomach? What was that? I don't know. But, oh, here, wait. There's some noise. This radio has no antenna. I'll go from being the audio injector. I will now be the antenna injector. Okay, let's just look at these antenna connections up here and see what they are doing. So one screw straight to the chassis here. And the other screw is the antenna. Okay, radio turned up. Band is broadcast band. Audio still making a little bit of noise there. Really a fat chance on this coming to life here. I think there's nothing going into this radio. So we're still stuck with a dead radio. She's still dead, Jim. Okay, troubleshooting is going to get a little more intense now. And I'm going to have to go and make up a plan of how to approach this exactly. So, but, you know, no smoke, no fires. That's pretty good. I like that. And I'm off to enjoy my day. Yesterday was rainy. Today is going to be sunny and cool. Fantastic. Thanks a lot for watching, and see you on the next video.